This comes in extremely handy for us to do things that involve dynamic computations. So in this situation we have dynamic computations because we have basically our timeline split up. We find that for the first year we get paid 0.2% compounded monthly. So I'll split this up as year 1. So this is 1 year. And we get paid 0.2% per month. Sorry, I shouldn't say per month. I should say compounded monthly. So 0.2% compounded monthly. I'll write it like that, C/MO. So 0.2% compounded monthly over this first 1 year period. Now, initially I'm going to spend $200. So I'm going to erase this inflow and outflow so I can write down here. So initially I'll have an outflow of $200 because that's something of value leaving my possession. Now in the first year I'm really going to have to think about it as an inflow because after 1 year I find that I can earn a better rate somewhere else. So I'm going to withdraw that money and I'm going to put it in at another bank that's going to pay me 6.9% compounded daily. So I need to figure out what I'll have after 1 year in order to be able to go any further. So let's see here. Well, I'm going to start with the easier thing. So 0.2, oops, just enter anything in there. You don't have to really make sure these are all updated until you're ready to solve. So 0.2%, negative $200 initially, no payment. I don't know what I'm going to have in 1 year, but I know this is compounded monthly, so I'll hit 12. And remember we said earlier that this is going to be the number of these guys. So if I compounded monthly and I want to know the value in 1 year, this will be 12 compoundings times 1 year, which is exactly 12 months. So now I can calculate my future value. Now you don't need to delete it out or anything. Once you hit alpha and enter, it'll solve for it accordingly. So after 1 year, because of this low interest rate, I'll only have $200 and about 40 cents. Now banks always round down, by the way. They never round up. So you would have $200.40 even if it were 200.409. It'd still only give you 40 cents. So I'm going to list that as an inflow because I get that money at this time. And what I'm going to do is I'm going to reinvest it. So I'm going to take that full $200.40 and I'm going to put it in at 6.9% compounded daily. So I'm going to figure out what that's going to be worth in 2 more years. Alright, well, so what I'm going to change first is my present value is negative 200.4, no payment. I don't know what my future value is, but this is compounded daily, so we're assuming 365 days per year. That's the simplest thing we can do. Not 0.2%, but 6.9%. So be careful as you're adjusting these that you make all the according adjustments. Now this is going to be 2 years. Since we're paid 365 and little n is 365 and we want to go for 2 years, that's going to be a total of 730 compoundings. Now I can come down and solve for my future value, alpha, enter, and I find out that after a total of 3 years, I'll have $230.05. So I didn't do very well at all at these 2 interest rates. But see how this really nicely allows us to keep track of what's happening. You can color code it, you can make it prettier than I did, but this will do for us. Now we're not asking a question related to the present value, but we want to know what would you have to deposit today to have $900 as a future value at the end of the 3-year term. So our time diagram looks very similar. It's still going to be split up, 0 years, 1 year, and 3 years. And we're still going to be earning the same rates. This is going to be 0.2% compounded monthly. And this is going to be 6.9% compounded daily. And we know that over here we're going to have $900 as our future value. And we sort of have to work backwards. We need to figure out what is our initial outflow going to have to be. So we kind of have to figure out, well, what does this have to be? Now, before it was reinvested, what was the outflow there, or the inflow there? And that will lead us back to this point. So we kind of have a few little hurdles to jump over here. So the first thing I know is that my future value is a positive 900, since that's going to be an